Welcome to G Fun Facts Online. Today, we are journeying 97 light-years from Earth to explore a discovery that fundamentally changes how we view the universe. This is the story of GJ 9827d, the Steam World. For thousands of years, when humans looked up at the night sky, we saw a canvas for our myths. We saw gods and monsters in the stars. But as astronomy evolved into a rigorous science, a new question took hold. Is our home unique? Earth is defined by water. It shapes our geology, regulates our climate, and acts as the solvent for life. Because of this, astronomers have spent decades hunting for an Earth 2.0 rocky worlds where liquid water pools on the surface. But the universe is far more creative than we give it credit for. It doesn't just copy Earth, it iterates. We have found hot Jupiters, diamond planets, and now, we have confirmed the existence of a new class of planet entirely, the Steam World. The characterization of exoplanet GJ 9827d is a watershed moment. It is not a rocky Earth, and it is not a gas giant like Neptune. It is a missing link. It is a world where the atmosphere is not air, but scalding steam, and where the oceans do not roll on the surface, but hang suspended in a thick, supercritical fog. This is the story of that world, the technology used to find it, and what it means for the search for life. To understand this planet, we first have to understand the sun that it orbits. The planet resides in the constellation Pisces the Fishes. This is an ancient constellation, but for modern astronomers, it holds a treasure. The star system is located about 97 to 100 light-years away. In cosmic terms, that is effectively our backyard. If the Milky Way galaxy were the size of a continent, this star would be a house down the street. This proximity is crucial because it makes the star bright enough for our telescopes to collect high-quality data. The star itself, designated GJ 9827, is a K-type main sequence star, often called an orange dwarf. These are the Goldilocks stars of the galaxy. They are smaller and cooler than our sun, but larger and brighter than the tiny volatile red dwarfs. While red dwarfs are famous for violent flares that strip atmospheres away, K-dwarfs like this one are generally more stable, offering a safer environment for planets to hold onto their air for billions of years. This star is about 60% the mass and radius of our sun, glowing with a warm orange light. But this star is not alone. It hosts a crowded system of planets. The Kepler Space Telescope revealed 3 worlds transiting this star. There is Planet B, a rocky super-Earth that whips around the star every 1.2 days, roasted and likely stripped bare. There is Planet C, orbiting every 3.6 days, also likely a bare rock. And then there is our subject, Planet D. It orbits every 6.2 days. Now, an orbit of 6 days places it incredibly close to the star, about 10 times closer than Mercury is to our sun. Even though the star is cooler than the sun, that proximity means GJ 9827d is hot. Surface temperatures are estimated to be around 350 to 400 degrees Celsius, or roughly 660 to 750 degrees Fahrenheit. This temperature profile tells us immediately that this is not a habitable world in the traditional sense. Liquid water cannot exist on a surface that hot. Yet, it is this specific combination of size and heat that makes it the perfect laboratory for science. This discovery didn't happen in a vacuum. It arrived to solve a specific statistical mystery known as the radius valley. When the Kepler mission found thousands of exoplanets, astronomers noticed a strange pattern. There were plenty of rocky planets, up to about 1.5 times the size of Earth. There were also plenty of gaseous planets, starting around 2 to 2.5 times the size of Earth. But in between, there was a gap, a scarcity of planets. This became known as the Fulton Gap, or the radius valley. The leading theory to explain this is photoevaporation. The idea is that planets form with rocky cores and pull in thick atmospheres of hydrogen gas. If a planet is too small and too close to its star, the star's radiation boils that atmosphere away, leaving a naked rock. If the planet is massive enough, gravity holds onto the gas, and it stays a puffy mini Neptune. The valley represents the dividing line where you either lose everything or keep it all. But this theory had a hole in it. It didn't account for water. Water molecules are heavy, much heavier than hydrogen. A heavy atmosphere is harder to strip away. If a planet were made of a significant amount of water, it might sit right in the middle of that radius valley, defying the simple rock versus gas classification. GJ 9827d sits exactly on this boundary. It is twice the diameter of Earth and about 3.4 times the mass. It is a classic sub-Neptune by size. But for years we didn't know if it was a rocky ball with a hydrogen cloud or something else. We needed to taste the light to find out. This brings us to the detective work involving transmission spectroscopy. Imagine a firefly buzzing around a massive lighthouse beam. When the firefly passes in front of the light, it blocks a tiny fraction of the photons. If the firefly is surrounded by a cloud of colored smoke, the solid body blocks light completely, but the smoke lets some light through, absorbing specific colors. Every molecule in the universe absorbs light at specific wavelengths, its chemical fingerprint. Water vapor is famous for absorbing infrared light. When GJ 9827d passes in front of its orange sun, the starlight filters through the planet's atmospheric rim. By analyzing that filtered light, astronomers look for the missing chunks of the rainbow. The first major breakthrough came from the Hubble Space Telescope. A team observing the planet over 11 separate transits managed to stack the data and find a distinct absorption feature at 1.4 microns. This is the classic signature of water vapor. It was the smallest exoplanet ever found to have a detected atmosphere. But Hubble had limits. It couldn't tell if the planet was a hydrogen balloon with a little bit of water, or a true water world. For that, we needed the James Webb Space Telescope. Using its NIRISS instrument, JWST stared at the planet and provided staggering data. It confirmed the water, but more importantly, it measured the shape of the signal. If the atmosphere were made of light hydrogen, it would be puffy and extend far into space, creating a massive signal. If the atmosphere were made of heavy molecules like water, gravity would compress it closer to the surface. The JWST data showed a compact feature. This ruled out the hydrogen model. The best fit model suggests an atmosphere that could be anywhere from 30% to nearly 100% water vapor. This was the smoking gun. GJ 9827d is not a gas dwarf, it is a steam world. So what does it actually mean to be a steam world? We have to leave our earthly intuition behind. On Earth, we are used to water boiling into steam at 100 degrees Celsius. But physics gets strange when you crank up the pressure. On the surface of Venus, the pressure is 92 times that of Earth. On GJ 9827d, the pressure at the bottom of the atmosphere could be hundreds or thousands of times higher. With a temperature of 400 degrees Celsius, we are dealing with something called the critical point. For water, the critical point occurs at 374 degrees Celsius and 218 bars of pressure. Above this point, the distinction between liquid and gas vanishes. The substance becomes a supercritical fluid. A supercritical fluid has properties of both liquid and gas. It can move through solids like a gas, but dissolve materials like a liquid. There is no surface tension. There is no ocean surface. If you were to descend into GJ 9827d, there would be no splashdown. You would start in a thin, hot layer of water vapor, steam clouds illuminated by the massive orange sun. As you drop deeper, the pressure rises, the steam becomes denser. The sky would likely be a hazy white or gray. The heat becomes oppressive, surpassing the temperature of a pizza oven. Eventually, you wouldn't hit water. The steam around you would simply thicken into a fog, and then a dense fluid. Visibility drops to zero. You are swimming in supercritical water. Deeper still, the pressure becomes so crushing that water is forced into exotic solid states, known as high-pressure ice, hot, crystalline solids, denser than liquid water. Beneath that, a rocky core. It is a world of continuous fluid, a global sauna that never ends. But how does such a world come to exist? This is where planetary forensics comes in. Water is volatile. In the early solar system, close to a star, it is too hot for water to freeze into ice grains. It stays as vapor. Planets form by gathering solid grains. Therefore, planets that form close to their star are usually dry rocks, like Mercury or Earth. Earth only got its water later from comet impacts. But GJ 9827d is made of up to 50% water, yet it sits right next to the star. This implies it did not form where it is today. The prevailing theory is planetary migration. The planet likely formed far away, in the cold outer reaches of the system where ice was abundant. It gathered a rocky core and a massive shell of water ice. Then, over millions of years, it spiraled inward toward the star. As it arrived at its current, hot orbit, the ice melted and the surface sublimated, turning the frozen shell into the steam atmosphere we see today. It is also possible that GJ 9827d started as a mini Neptune with a thick hydrogen envelope. Over billions of years, the intense radiation from the star stripped away the light hydrogen, but left the heavier water behind. What we are seeing today is the skeleton of a planet, the heavy volatile core revealed after the atmosphere was peeled away. This makes the planet a pivotal case study for understanding how solar systems evolve. To really appreciate this world, we should compare it to our neighbors. Earth is a rock with a thin coat of wet paint. Our water is less than 0.05% of our mass. GJ 9827d is a true water world. Interestingly, the best analogs might not be planets, but moons. Europa, orbiting Jupiter, and Enceladus, orbiting Saturn, are water worlds with rocky cores and global oceans topped by ice. If you took Europa, moved it close to the sun, and melted the ice shell, you would get a smaller version of GJ 9827d. It is essentially a thawed-out super Europa. Now the question everyone asks, is there life? The short answer is, almost certainly not. Life as we know it requires complex organic molecules, like proteins and DNA, which break down at high temperatures. At 400 degrees Celsius, proteins cook instantly. The pressure and the supercritical nature of the fluid would destroy cell membranes. However, simply finding this world is a victory for astrobiology. It serves as a proof of concept. It proves that atmospheres exist on small planets and aren't always stripped away. It proves we can detect heavy molecules like water, which are much harder to see than hydrogen. And it proves that the diversity of planets is real. If we can detect water steam on a hot, dead world today, it means that tomorrow, we might detect water vapor on a cooler, habitable world. GJ 9827d is the training ground for the telescopes and models we will use to find Earth 2.0. Looking ahead, astronomers will point the James Webb Telescope back at this system to look for other molecules, like carbon dioxide or methane. The upcoming extremely large telescopes on the ground will also target it to measure wind speeds. But for now, the characterization of GJ 9827d as a steam world stands as a humbling reminder of our limited perspective. For centuries, we divided planets into terrestrial rocks and Jovian gas giants. We thought those were the only options. This discovery breaks that binary. It introduces the volatile rich world. It suggests that water is not just a rarity, but a fundamental building block that can make up the bulk of a planet's mass. As we continue to scan the heavens, we will likely find that GJ 9827d is not an oddity, but a member of a vast silent majority. The galaxy may be teeming with steam worlds, hot saunas orbiting orange stars, their supercritical oceans hiding secrets in the deep, crushing dark. While we cannot swim in the oceans of GJ 9827d, its discovery tells us that the story of water in the cosmos is far wetter, far stranger, and far more wonderful than we ever dared to imagine. Thanks for listening to G Fun Facts Online.